Hey, I'm just going to make a quick video about something called the Spearman's correlation. So let's jump right into it. So remember, a correlation coefficient measures the extent between which two variables tend to change together. So the coefficient describes both the strength and the direction of the relationship. So again, remember, if I want to talk about murder rates and ice cream sales, there might look like there's a positive correlation between the two, but really there's a confounding variable affecting both of them, and that is when the temperature increases, such as in the summer, murder rates increase, and so do ice cream rates. So that's a way that we can measure the correlation. This does not give any indication if we should be making the correlation. This is just the strength and the direction of looking at two different variables. And there's two different ones. So in the last section, you learned about the Pearson correlation coefficient, which was R. So we use R for two different things, and I didn't want to confuse you in that last one. We use it for the Pearson correlation coefficient, and we use them for something called Spearman's. Now remember, the Pearson correlation evaluates the linear relationship between the two covariance variables. And remember, a relationship is linear when one change in one variable is associated with the proportional change of another variable. So for an example, you might want to use the Pearson correlation if you evaluate whether increases in temperature at your production facility are associated with decreasing thickness of your chocolate coating. So then another one we can use is called the Spearman rank order correlation. So it evaluates the relationship between two continuous or ordinal variables. So that's basically, while there's more onto the screen, that's really what's going on. So it uses rank data instead to look at other than just raw data. So we use this a lot when evaluating relationships between ordinal variables. For example, you may want to use it to evaluate whether the order in which employees complete a test exercise is related to the number of months they've been employed. Okay, the ordered one, that one is again how you ordered them and how they completed something. Okay, so again, it evaluates. Oops, this is a duplicate slide. Okay, so here's the information of where to find it. All right, so how to get the Spearman rank order correlation. All right, you can do it in Minitab, and it's really easy. So I'm going to show you how to do that now. And again, here's the link to get the shipping data. Let me do that. Well, let me go to it. No. Okay, I'm going to break out of it. I'm going to go get this data. Okay, and then I'm going to put it, and I'm going to show you what to do with it. I'm going to put it in my web browser, and I'm going to go here, and I'm going to go down here, and I'm going to download it, and it downloads it as a workshop. So I'm going to put it here. I already have it there. So then what I do is if I click on it and do open, it automatically opens Minitab. Okay, and I can show the data down here. I'm going to bring this up so you can see it better. Got my data right there. So I'm going to go to Stats, Basic Statistics, and Correlation. All right, I'm going to do, and I tell you this in the PowerPoint. I tell you what to pick first. So I'm going to do distance because that's my X variable. That's my independent variable. I can't change the distance somebody lives from the center. Oh, I'm sorry. Let me back up. I'm jumping and I don't mean to. Okay, so let's go back. So I'm looking at this data, and what this data is, it's information from a shipping center, kind of like think of an Amazon hub or a trucking facility. And I want to know if there's a correlation between a distance a package is delivered and the days it takes to ship to a shipping center. So again, my independent variable is the distance that I can't change, and my Y is the days it takes to ship something. So I'm going to go back and do that. Okay. So when you're doing this, you do the distance first. And remember what I did is I went over here, I clicked on it, and then I clicked on days. Then I go to options. You can do the Pearson or the Spearman's. Because we have an ordered set of data, I'm going to put Spearman's. Okay, and I'm going to hit OK and hit OK again. And look what it does for me. It makes the scatter plot, and look at this data. It is all over the place. There is no pattern to it. And down here, it gives me the R value and the confidence interval. You don't need to worry about the confidence interval, but what you do need to worry about is the R value, okay? And again, I can copy and paste it if you want to. You can copy the graph, and that's what I did to put it into the PowerPoint. So let's go here. So here's the scatter plot. So this shows me that there is a positive and very, very weak correlation. So it's really close to zero. So there's really nothing going on. And if I look at the data, yeah, I don't see there's no linear relationship between the two. The data is completely scattered. So it really doesn't make a difference how far somebody is from the facility and the number of days it takes to get it to the customer. And again, think of reasons why it could be. Maybe there's things that they can ship really fast regardless of location. And maybe there's things that take longer. And even if you live really close, there's built in times for it to ship because they may not get it there. It may have to be packaged special. You may have certain trucking companies that only come on days to get it out. So there's a lot of different reasons why this could be occurring.